Alright, so I'm really excited to record this stats video using some new technology that I got from another stats teacher at Yes Prep Southeast on how I can actually just be solving my problem and record this as I go along. I'm really excited, and I think this can be actually a new way where we do a lot of problems. So the request was for problem 1B on the problem set 5-2. And this is a problem talking about eggs. And the first question says the weights of the empty cardboard containers have a mean of 20 grams. So the expected value of the containers, which is the mean of the containers, equals 20 grams. And the standard deviation of the containers equals 1.7 grams. It is reasonable to assume independence between the weights of the cardboard containers and the weights of the eggs. It is reasonable to assume independence among the weights of the 12 eggs that are selected to form a carton. Let X is equal to the weight of a single egg. So part I says to find what is the mean of X. Well, I know that the mean of the total, which is the carton plus the eggs, has a mean of 840. So 840 must equal 12 times the eggs, because there are 12 eggs, plus the weight of the carton by itself, which is 20 grams. Now minus 20 on both sides. And remember, this equation was 840 was the total container with the eggs, and that has equaled 12 times the weight of the eggs plus 20, which is the weight on average of the empty carton. So 820 equals 12x divided by 12 divided by 12. Let me check on my calculator over here. Actually, I don't have a calculator on me. I'm doing this, I've already done this problem. Anyways, 68.3 repeating grams is equal to X. Alright. Now on II, they ask us what is the standard deviation of X. I actually solved this problem incorrectly the first time I solved it, and I think I misled some students when I was explaining how to solve this, and I apologize for that mistake. In fact, I just had to read up on a math forum a subtle distinction that I missed, and I apologize for not teaching this distinction in class. I actually didn't think it would come up, but it did. Anyways, the way to solve this problem is we know that the standard deviation of the total is equal to 7.9. Okay. Well, the standard deviation of total is 7.9. So the formula for standard deviation is going to be equal to square root of 12. Standard deviation of the total carton will be 12 times the standard deviation of the eggs, so of X, plus the standard deviation of the carton. Now, when I told some people, of course we need to square this. When I told some people how to do this, I said to square this also, which is what I had been teaching you from the beginning of the year. You remember we did problems like this, where I'll do it over here to the side, where it was John is going to India, and this is how much money he has. What's the standard deviation going to be? Well, and then we would say, well, the standard deviation of this, if you all remember, this was before the first exam, first common assessment. We said the standard deviation of this will be the square root of 43 squared times the standard deviation of S squared plus the standard deviation of B squared. The problem is, or the difference between this situation where we square the 43 and this situation where we simply use the regular 12 is the following. Here, this 43 was a constant. If the 43 is a constant, we need to square it. Here, the 12 is not a constant. The 12 represents the fact that we have 12 eggs. It's not that I'm taking one egg and multiplying it by 12, it's that I'm taking 12 individual eggs and combining them. This is not a constant. This represents the 12 eggs. This here was a constant, 43. It's just multiplying by 43. We square the constants. We do not square this. I know it's a subtle distinction. I know it's a little bit weird and confusing. In fact, I had to read it, as I said, I read it tonight on a math forum. And I can explain it more in class. The bottom line is, we do not square this 12 because the 12 does not represent a constant. Now this problem is solvable. So I have standard deviation of t, 7.9, equals square root of 12 times standard deviation of x squared, which I have no idea, plus standard deviation of the carton, 1.7. How do I solve this? Well, I'm going to square both sides. So I have 7.9 squared equals 12 standard deviation of x squared plus 1.7 squared minus this over here, divide everything by 12. Take the square root. So my final answer will be, and I apologize for running out of a little bit of space here, I'm going to minus my 1.7 squared, so I have 7.9 squared minus 1.7 squared, all divided by 12. Take the square root of the whole thing, and I will get, let me see, what do we get? Well, I don't have this done on my calculator yet. If you'll bear with me, I will go and solve this. I believe you get 2 points. Give me 1 second, please. I'm going to pause the video here. Give me 1 quick second here. We will get 2.23 grams. So again, I think part 2, double I is a little bit more complicated, but the key thing is the total standard deviation 7.9. We know the standard deviation of the total is equal to the square root of 12 times the standard deviation of x squared plus the standard deviation of the carton squared. Again, the reason we don't square this is not a constant like it was in this case over here. This is rather representing the 12 eggs. We know what standard deviation is here, 7.9. This is 1.7. Solve it out. We get 2.23. Hope this video helped. I'm happy to make more videos if that's helpful.